Okay, so I'm going to give you the definitions first of all, and then we're going to talk about safety. First of all, has anyone heard these being separate before? Accuracy versus precision? Do you remember? Remind me your name again.
Brendan?
Brendan, go ahead. Do you know anything different about this?
Is it accuracy they're the same, but on target? Precision they're the same, not on target?
Pretty much. The idea is it's a question of, are you talking about measurements being close to each other, or are you talking about measurements being correct? Right. So let me write these definitions down, and then I'll give you an example. So when we talk about accuracy, accuracy is how close a measurement is to the true value. Hey, gentlemen. Eyes forward, please. So, accuracy is how close a measurement is to the true value, versus precision is how consistent a set of measurements are. And the easiest way that I have to illustrate this difference is, and I think this is kind of what Brendan was talking about, but the easiest way that I have to illustrate this difference is I'm going to imagine targets, like if you're shooting a bow and arrow at targets, we're going to use that to illustrate the idea of accuracy and precision. So precision, again, means can you be consistent, right? It has nothing to do with whether you're right or not. It's just, are you consistent? And so, for example, if I could hit this spot on the target every time, that would be an example of me being very precise, even if I'm not accurate. So this is an example of precise but not accurate. So I can repeat that measurement a lot, right? But it's not quite right. Maybe I get pretty close to the center, but I'm not very consistent. That would be an example of accurate but not precise. And obviously, the goal for a measurement is to be both accurate and precise. And I'm going to give you the other one, which is if you do something like this, we have a very technical word for something like this. We call it garbage. Any questions so far? Now I want to talk about how you can make a measurement. So this is the targets are the way of thinking about it. But when we think about accuracy and precision, so let's talk about accuracy first. So let's say that you had a watch and you were measuring time. But that watch, instead of it ticking every second, let's say it ticked every 1.1 seconds. So it's just a little bit off in terms of how it kept time. Every time you use that watch to measure something, you could get the same reading. So you could still have a very precise watch. But the watch is wrong. It's not accurate because because the second is the wrong one. Another example here. So I have here this is a meter stick, and assuming assuming this is the correct length, this would be an accurate meter stick. But this, if I use this side of my meter stick, it's not a very precise meter stick, right? So if you use this part, but it's just labeled 1 meter, right? And I try to measure this desk, I don't know what it is. About half a meter. Maybe you're saying, oh, maybe it's more like 0.6 meters. Maybe you're saying it's more like 0.7 meters. I don't know. So it'd be hard to get the same measurement multiple times using this side of the meter stick. If I use something like this, where I've got my meter stick broken into tenths, right? So this meter stick would get closest to the nearest 10 centimeters. So I can be a little bit more precise with this, right? But as I get more and more divisions on my ruler, I can get even more and more precise. So if I broke my meter into 100 parts, I'd be even more precise. Or if I broke it into 1,000 parts, I'd be even more precise. Because I could get the same measurement multiple times. But that has nothing to do with the accuracy, right? As long as this is a meter long, it's accurate. But if I don't have as many marks on it, it's not quite as precise. So precision is the ability to be consistent, and accuracy is the ability to be close to the true value. I'm going to give you one other thing, and then we're going to do a practice lab as a group, as a class. The last thing I want to define is something called percent error. Percent error is a way to quantify the accuracy of a measurement. When I say quantify, all I mean by that is quantify just means to turn it into a number. I want a number that says how accurate it was. So if you have a perfectly accurate measurement, you would say it had 0% error. This has an equation that goes with it. Now, I'm not going to ask you to memorize the equation because I always have the equation posted here. And if you ever need to use it, I'll put it on anytime you ever need to use it, I'll write it down for you. But I want you to be familiar with what it is. The percent error equation is this. Percent error equals the absolute value of the measured value minus the expected value divided by the expected value times 100.